Now let's take a look at example 8. Now 8 is actually a little bit more difficult than the previous two examples, but it is the same. Okay, it all leverages on the inverse norm. Okay, now 8 says that there is this normal random variable x with unknown mean m, known variance 5. Okay, now they want you to find the least integer m such that probability x bigger than 8 is bigger than or equals to 0.02. Now there are two methods here that we want to show you. Now the first method will be using the information that we already know, which is this probability x bigger than 8 bigger than or equals to 0.02. Now I'm going to use inverse norm later, so that means the first thing I want to do is to change the bigger than sign to a less than sign. So I can use the complementary method to get this. Okay, so this is my new information. Next, before I use inverse norm, I need to standardize. So I can very quickly standardize to get this. Okay, so probability z less than or equals to 8 minus m, m is the mean, divided by square root 5. Okay, why square root 5? Because 5 is sigma square. So that's why sigma is square root 5. Okay, less than or equals to 0.98, where z is the standard normal. Now, before we continue, now I'm going to ask you to draw a very simple bell shape first. Now, this is your simple bell curve. Now, it's symmetric about the mean mu, and then can you strike away this 8 first? And then this 0.98. Now, just imagine this unshaded region, okay, which is now I'm shading. Okay, just tell yourself that I want this to be 0.98. Okay, if I want this to be 0.98, then if I call this number A, then what I'm writing actually, I'm drawing actually rather is probability x less than or equals to A is 0.98. Now inverse norm, okay, using 0.98 will give me the value of A. Okay, if you press this out in your GC, you'll get 2.0537 for A. Okay, let's put that down here. That means this number is 2.0537. Okay, this number here. Now, if that's the case, then look at what we have here. Now, I have z less than or equals to, or rather probably z less than or equals to some number here. This number is 8 minus m over root 5, and I will have it less than 0.98. Now, if that's the case, then this number must be a number to the left of 2.0537. Now, why is that so? Because this shaded region, alright, is 0.98. And this number here, okay, z less than or equals to this number here, the probability is less than 0.98 or less than or equals to 0.98, which means that this number must always be on the left of 2.0537. It has got to be somewhere on the left. Now, why is that so? Alright, because if that number is here, then the total probability will be this part, the one that I'm shading in blue, plus the part in green. But the part in green is already 0.98. So, the combined area will definitely be bigger than 0.98, which is something that I don't want. I only want less than or equals to 0.98. So that tells me that my 2.0537, alright, must be a number that is bigger than 8 minus m over root 5. So now all it remains for us to do is to make m the subject. So you cross multiply, make m the subject, you get this answer. Now m is bigger than or equals to 3.4077. Alright, it's not your final answer because the question wants the least integer value m. So that means your least integer value m must be 4. Alright? Now the second method is actually a GC method. Okay, now let's take a look at what we have been given. We have been given this. Probability x bigger than 8 is bigger than or equals to 0.02. Now remember, I want to find the least integer m for this to happen. So let's look carefully at this line. And then this line is actually your x bounded by 8 and infinity. Okay, to be bigger than or equals to 0.02. Now this piece here is your norm CDF. So if you key this into your GC, okay, what do I mean? You go to your Y and then you key in your norm CDF inside. Okay, the mean, or rather the lower limit is 8, the upper limit is infinity. Okay, can you see that? Lower limit 8, upper limit infinity. Then in place of my mean, I use x. I know that the variance is 5, so the sigma is √5. So I key this into my y1. And the reason why I want to do this is because I want to generate the table. Okay, the table of probabilities. Now when I press second graph, okay, I will get this table. Now remember, this is my probability x bigger than 8. Now I want the probability x bigger than 8 to be bigger than 0.02. I want the least m for this to happen. So all I need to do is to look at the y column. I want this column to have a number that is bigger than 0.02 for the very first time. So if I look at 1, this is a very small number. 2, this number is still below 0.02, and this number 0.012 is getting closer to my 0.02 but still lower than that. And then I realize that 4 is the first time that the probability is bigger than or equals to 0.02. So that tells me the least value that I'm looking for is 4. Okay? How do you present your answer? What you do is you tell people that you are using your GC. Okay? You can see that the answer is 4. So you have to present your case with x equals to 4 as well as x equals to 3 and 5. The answer itself, the answer before it, the probability before it, and the probability after it. Okay, so you can see the probability that you want bigger than 0.02, the probability before it 0.01267, and the probability after that 0.08986. Okay, you want to show in your presentation that this is the first instance that the probability has gone above 0.02. So hence the answer must be 4. Done.